Hey everybody, Paul Rothrock here, pgEdge Solutions Engineer. It might be summer for most of us, but we just released something pretty cool. pgEdge ColdFront, a lightweight, open source, transparent data tiering system built on stock Postgres. It cuts storage bills by up to 90% while seamlessly serving all three workloads on one table. OLTP for your live app, analytics at columnar speed over your full history, and AI pipelines that can reach every row you've ever stored, with no vendor lock-in and no application changes. Let's dig into it. Postgres databases grow over time. There's no way around it, but unlimited data growth presents a huge problem. If you keep all the data on live databases, you end up with a huge storage bill, long maintenance windows, and even longer backup times, mostly for data that you haven't touched in months. You can get around this by deleting or dumping it to files, but now it's either gone or unreachable. You could go with a proprietary tiering technology, but now you're locked into a vendor for as long as you need that data, which could be a decade or more depending on your compliance needs. And you'll still have a separate system to update and maintain. Wouldn't it be great to seamlessly unite AI, analytical, and OLTP workloads in one table using standard Postgres? That's why we created pgEdge ColdFront. It creates one table in two tiers. Hot data stored on your standard Postgres data files, with cold data stored in Apache Iceberg on an object store like S3. Applications run SQL statements against the same table on the same connection, with reads and writes across both hot and cold tiers, running on stock Postgres 16 or higher, with 90% cheaper storage for your archival data. Lots of archival storage systems brag about reducing storage costs, but one key difference is that pgEdge ColdFront keeps your cold data writable. This is hugely important for a lot of use cases. For industries like financial services or life sciences, you need to keep data for decades while still being able to have it on hand for audits. And you still might even need to make updates with new information. ColdFront lets you query data like it's in one table, even writes, making auditing and corrections as simple as one query. So how does it work? Well, a big focus for pgEdge ColdFront was to make it minimally intrusive. Postgres servers already work hard enough. Adding a sidecar process or remote procedure calls just makes things harder. ColdFront starts with a simple C extension in Postgres that routes queries to the correct tier. Cold tier data is stored in Iceberg files, which are queried via pgDuckDB in the same process. Finally, a small Go binary run via cron handles moving data from hot to cold. The only extra service is Lakekeeper, which provides an API to manage the Iceberg files. This simplicity makes it easy to deploy, and because it's using open file formats and open source software, you have zero vendor lock-in. Now let's take a look at pgEdge ColdFront in action. Let's get started with Docker. The first step is to build the archiver and partitioner binaries. Then we'll build the Docker images that contain the ColdFront extension and a patched version of DuckDB. After a quick coffee break, we can start the Docker containers. I'm going to use the local seaweed.fs store, so I'll add that profile flag. This will handle building the extensions from source and installing them in Postgres. And it also sets up a local Lakekeeper container and a local seaweed.fs container. Then we'll perform some curl commands to get the Lakekeeper set up. First, we'll accept the terms of use. Next, we'll set up a warehouse in Lakekeeper. Mine will point to the local storage, but this is where you'd specify another object store. And finally, we add that warehouse to the default namespace. Next, we'll enable the ColdFront and pgDuckDB extensions and set up the credentials for object storage with ColdFront. Now we're ready to start using it. First, let's create a time series partition table and a partition for it. I've already got the table set up in my archiver configuration as well. Once that's done, every time the archiver runs, it will move cold data to Iceberg storage automatically. ColdFront also gives the ability to have Iceberg-Only tables. All the data from these tables will live in the Iceberg storage layer, with Postgres providing a front end for them. Creating one is just one SQL call using the ColdFront extension. As you can see, this table is created as a view, and it's using pgDuckDB to interact with the Iceberg files to give you impressive query speeds. Finally, if you're not ready to use Iceberg storage, you can set up a normal table and use our partitioner binary to automatically create partitions as needed. To do that, we can create a partition table like before. Then we can run this command to register the table with the partitioner. Now you've got a table that will be automatically partitioned on your schedule, and when you need to reduce storage costs, you can move them to Iceberg just by adding an entry to the archiver configuration. And that's pgEdge ColdFront, one Postgres table that seamlessly serves all three of your workloads: OLTP, analytics, and AI. Open source at every layer, no vendor lock-in, no application changes, and storage bills up to 90% cooler. If you got tables full of data you're paying SSD prices to never touch, ColdFront's worth a try, so head to the link in the description to kick the tires. Leave a like if you learned something, and be sure to subscribe and hit the bell for more new cool stuff from pgEdge. Thanks for watching.